Hello class, let's continue with subtopic 1.5, which, if you remember, is loss of exponents with integer exponents and introduction to logarithms. So this is the part 4 of this subtopic, guys. And today's lesson will be, one more time, highly conceptual. I want you to understand the concept, one of the concepts that I'm going to teach you, instead of doing exercises and all these things. So this is strongly conceptual. Okay, so let's look at this, guys. Let's look at this statement that I'm writing to you right here. It says, be careful with what you write, because what you write may not make sense. And I'm gonna give you several examples, both in mathematics and in other fields of knowledge in which this is applicable. For example, look at this question. What is the square root of a shoe? It's a question that I'm asking you. What is the square root of a shoe? What would you answer to a person that asks you this question? Like, what would you say to this person? Well, what you would say is that even though the question is posed apparently correctly, like you have all the ingredients, all the grammatical ingredients that make up a question, the question makes no sense, right? Because what is the square root of a shoe does not have an answer. Like, this is completely nonsensical, and therefore you even though you can ask the question like I'm doing right now, I can write what is the square root of a shoe. Even though I can write this question perfectly fine, grammatically okay, the question is nonsensical and doesn't deserve an answer. Okay, if somebody asks you this, you can completely reject answering the question because it doesn't make sense. Number 2, the length of your love is 3 meters. Another statement that although grammatically correct, this is, I believe this is perfectly correct. I'm not an expert in grammar, but I think so. It sounds good, etc. It doesn't make sense. Why not? Because we're trying to assign a physical quantity, which is length, to an abstract concept such as love, which does not have physical characteristics like as length, right? This concept that we have of love does not have something called length, and therefore somebody saying this, the length of your love is 3 meters, is making nonsense. Okay, this is not a good statement. It's not logical, it's nonsensical, even though grammatically is correct. Okay, let's move on to examples in the realm of mathematics, even though this one looked a little bit like mathematics, right, because of the square root. Okay, look at this, guys. What if you see somebody write the following: 3 plus equals 3 plus equals. Does this statement, or does this expression rather, does this make sense to you? Writing this 3 plus equals, trying to add this thing to 3, does that make sense? Clearly not, because our understanding of this symbol and this symbol and this symbol does not allow us to write this expression and make it logical or senseful. We understand expressions like this: 3 plus 2, that's a good expression. 5 plus 1/2, that is a good expression, perfectly logical and senseful expressions. But something like this, even though resembles these other two, this makes no sense, because we are abusing the meaning of this symbol. We're using this symbol in an inappropriate way. What about this? And you know, I see a lot of students do things like this every now and then. For example, you have the binomial to the square, and we know, it's because it's very easy, that when you raise a binomial to the square, you get this, right? A perfect square trinomial. A plus b to the square is equal to a squared plus 2ab plus b squared. But a lot of students write this arrow, which I've told you means then. This arrow in mathematics should be read as then. And what this arrow means is an implication. It basically means that something that you know, some statement A, leads you to some statement B. Okay? For example, I was outside today in the cold. Okay, this is a statement. This is an affirmation. I was outside today in the cold. Okay, fine. Then I will probably get sick. This is another affirmation. Even though it's an affirmation in probability, it's another statement. Well, let's say that I will. Let's suppose that you're sure. I will get sick. Okay, so this is red. I was outside today in the cold, then I will get sick. So this is an implication. This arrow it basically means an implication. It means that you know something before, and then by doing some logic, then you can arrive at some other affirmation. Okay, once you understand the meaning of this symbol, of the then symbol, then you can see that it's used incorrectly here. Because this is not what you're trying to say. You're not trying to say that a plus b squared, then a squared plus 2ab plus b squared. That doesn't make sense, because in here you're not making any affirmation. You're just writing an expression, a plus b squared. Okay, that's just an expression. You're not affirming anything. What people are trying to say when somebody writes this, all of this, what they really have in mind is saying this, that a plus b to the square is equal to a squared plus 2ab plus b squared. And you know, I'm not being picky, you know what I mean? Somebody may say, teacher, you're just being way too picky or something. No, the way in which you use symbols in mathematics, has to be perfect, has to be really careful, because otherwise you may not make sense. So this is the correct way to write what this person had in mind, but not with the then. That would be incorrect. This would be correct, even though people can understand what you're trying to say. You need to be extremely careful. You need to be extremely careful in everyday language, and even more so when you're doing mathematics, because mathematics is a language of perfection as much as we can. Okay, it's the most perfect language we have created, and we have created this for a reason. Okay, so be careful with what you write, because what you write may not make sense. Why am I telling you this, guys? Why did I begin this class with these examples? Okay, let's see. There was a reason for that. This topic is about the laws of exponents with integer exponents. Okay, for example, we already discovered that a to the x times a to the y is equal to a to the x plus y, right? But if you remember, guys, first of all, we defined what this symbol meant, a to the x, and that meant a times a times a times etc. times a. How many times? X times. This is the definition that we gave to this symbol, a to the x, and I told you we are strictly restricting ourselves for x being a positive integer. That's the first thing I told you, guys. And if you want me to give you evidence of that, here it is. This is the workbook 1.5, and look at the first exercise. Define the symbol a to the x for a being a real number. With a, there really is no problem. A can be any number. That's just fine. And x being a positive integer. I'm being way too restrictive here. X has to be an integer and it has to be positive. Okay? Why? Why am I making this restriction? Well, because of this definition that I'm giving you. I'm saying, let's define this symbol a to the x as this: a times a times a times a, etc., an x number of times. And the reason why I have to make this restriction, x being a positive integer, is because of the following. If I make this definition, and if I don't restrict myself to this, well, I'm gonna be very redundant, to this restriction, then what can happen is this, guys. You can write 2 to the 0, okay, like completely nonchalantly, and we're gonna run into a problem. We're gonna run into a nonsensical statement. I'm sorry, a nonsensical expression. This is an expression. What makes this nonsensical? Because if this is the definition that I gave you, that a to the x is equal to a times a times a blah 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 times a x times, then what does it mean to multiply the number 2 0 times by itself? Because I understand what this means. Given this definition, I perfectly understand what this symbol means. This symbol means 2 times 2 times 2. Why 3 times? Because it's as many times as I'm being told by the exponent. 3 times. So this is perfectly, given this definition, this expression is perfectly understood. Perfectly. There is no doubt. This is perfectly understood. It's just 2 times 2 times 2 times 2. 2 to the 1 is just 2. But what could be this? 2 to the 0. How do I multiply 2 by itself 0 times? What does that mean? You see the problem, guys? You see the problem? If I give this definition, I need to be strict with x and say, okay, x is just a positive integer, and therefore, at this point, guys, at this point in our understanding, this symbol 2 to the 0 makes no sense. It's nonsensical, just like these questions were. You see what I mean? Or just like, let me try to make another nonsensical statement. Let's add 4 plus a circle. What does that mean? Or let's raise a triangle to the 3rd power. What does that mean? They don't mean anything. Even though I can write the symbols down, they don't mean absolutely nothing, guys. The fact that you can write something in mathematics with good symbols and all does not mean it makes sense. At this point in our understanding, this symbol makes no sense. 2 to the 0 or any other number to the 0 at this point makes absolutely no sense. And the same goes with this. I mean, if this was bad, this is even worse. Because what could it mean? Let me clean this a little bit. Because what could it mean? What could it mean to multiply the number 2 by itself minus 2 times? I'm going to repeat that. What could it mean? What could possibly mean to multiply the number 2 by itself minus 2 times? What? I mean, it's completely nonsensical. You see what I mean? So even though you can perfectly write the symbol 2 to the minus 2 or 3 to the minus 5 or whatever you want, 1/2 to the minus 8, even though you can write these things, guys, that doesn't mean that they have meaning at this point. At this point, of course, you know, because you have been told, right, that these symbols do have meaning, and that's what we're gonna find out. But at this point, given this definition, given the definition that we have given to this symbol, then we have to restrict ourselves to the exponent being a positive integer. Otherwise, my definition makes no sense, and I'm gonna be writing nonsense. That is the first thing I wanted to explain to you. Let's make a pause right there because I want to ask you stuff.